Alright guys, so today we're going to move on to the second part of triangle congruence proofs. Yesterday we just went with things that were given outright and what we could infer using our knowledge. Now we're going to build in some definitions. So when I'm given a geometry word, such as in example 1 where it says midpoint, there's something I have to do with that. So we're still going to go through that same process. What do I know? What can I infer? And what can I conclude? And then we're going to make our two-column proof. This isn't a whole lot more. It's just one extra step. Alright, so I'm going to start with what do I know? So that's what I'm given. I know that N is the midpoint. So I'm going to come over here and I'm just going to draw an arrow and say midpoint. Alright, of MO. So this whole segment right here, it's the midpoint. Alright, I also know that LM is congruent to OP. LM is congruent to OP. And I know that LN is congruent to PN. Alright, so those are the things I know. So N is the midpoint. That looks awful. Of MO. I know that LM is congruent to OP, and I know that LN is congruent to PN. Alright, so now that I've written down everything I know, what can I infer? Well, I know that midpoint needs a definition, because it's a geometry term that I'm using. So based off what I know about midpoints, I know that midpoint divides a segment in half. So if N is the midpoint of MO, then I can infer, it's not stated, but I can infer that MN is congruent to ON, because I know the definition of midpoint. Alright, so when I look at this, I see I have a side, and a side. So I am now ready to make my conclusion, which is that triangle LMN is congruent to triangle PON. And now I'm ready to write my two-column proof. So I start with my given statements. So N is midpoint of MO, and that's given. I know that LM is congruent to OP, that's given. I know that LN is congruent to PN. Oops, that should be a 2. That's given. Alright, so what did I infer? I inferred that MN is congruent to ON. And the reason that I was able to infer that is because it's just the definition of midpoint. I used the definition of midpoint to say, well, if that's the midpoint, then it divides it into 2 equal parts. And lastly, I was able to say that triangle LMN is congruent to triangle PON, and I used the side theorem. And when I look at this triangle, I see that it has an axis of symmetry right here, and that O and M are reflected. I see that this side reflects over here, and L and P are reflected, so it is a reflection. Alright, again, I'm going to go through those same questions. Example 2, what do I know? Alright, well, I know that JN bisects ML, and I know that angle M is congruent to angle L. Alright, so JN bisects ML. So this is the segment right here that is being bisected. And this is really important. You might get confused on this. Whenever I say JN bisects ML, JN is just the segment that's doing the bisecting. It is not bisected. So only the second term. So the second segment that's listed will be the one that's bisected. Okay, I also know that angle M is congruent to angle L. So I know JN bisects ML, and I know that angle M is congruent to angle L. All right, so that's all that I'm given. So now what can I infer? All right, well, I need to use this word bisect. Well, I know that bisect means to divide in half. So this segment is going to be divided in half so that LK is congruent to MK. And I know that because that's the definition of bisecting. I just used that term to infer something. So when I look at this, what else? I see I have an angle and a side, so I need something else. And when I look at it, I also see that I have some vertical angles. So angle, and I'm going to start with MKJ. You could say JKM, but I'm going to go MKJ is congruent to, so now I have to go the same direction. So M, I started with the 1 angle marker, so I have to go LKN. And I knew they were vertical angles. And I'm going to go ahead down here because I saw that I had to reverse the order of those letters as I wrote them, that this isn't a reflection, it's going to be a rotation. So I'm going to go ahead and write rotation down here. All right, so I have 2 angles and a side in the middle, so I can finally make my conclusion that triangle MJK is congruent to triangle LNK, and I know that because of angle, side, angle. And that side is sandwiched right in between those 2 angles. So my 2-column proof is JN bisects ML, and I know that because it's given. My second step is angle M is congruent to angle L. I know that because it's given. And then I concluded, or I inferred, that LK is congruent to MK, and I did that because it's the definition of bisect. I used that term and interpreted it. Okay, then I said that angle MKJ is congruent to angle LKN, and I knew that because they're vertical angles. And lastly, I said that triangle MJK is congruent to triangle LNK, and I knew that because of angle, side, angle. Alright, so I'd like you to try the remaining examples in this handout. Try them on your own, and then I will post the answers on Canvas, and if you get it right, then you can move on. If you get it wrong, I'll also have a video of it, so you can watch me think through it. And now remember, when you look at it, like I said here, if you labeled this as angle JKM, and then NKL. That means the same thing. I just went in a different order. So sometimes the order does matter, but when you're initially naming it, it's okay if you have it different as long as it's different over here. So just keep that in mind as you look at those examples. Also, if you had written these inferences in a different order, as long as you have, these are your givens, these are your inferences, and this is your conclusion. The order that you do them within those 2, it doesn't matter. All right, good luck.